Okay, good morning, everybody. This is Mr. Ainsworth. We're going to get into Unit 2 CIA test corrections here. So get out your red pen, do all corrections in red. Okay, so let's stop right there. Do all corrections in red. And if you're going to correct it well, obviously. And also do everything I tell you to do, because if you're going to have a second opportunity, you got to do things better. You got to do things differently. And in order to improve. So the first thing we do differently and better is do all corrections in red. If I don't see that, I'm not going to allow you to retest. All right, this is step one of a few steps in order to retest, and we'll talk about the steps 2 and 3 later. First thing you do is you fix your mistakes. So get out your red pen and directly on your test, whatever you missed, here we go. Circle your mistakes in red and then fix it off to the side. So like for example, just draw a line right here and do your corrections off to the side. Okay, so the very first thing we got to do is distribute through the -3. All right, if you're going to get this in slope-intercept form, all right, slope-intercept form is y equals mx plus b, as you guys should know. All right, these are some very basics that we've been working on for months. Then you need to isolate y. If you didn't know that, write that down, okay? That's obvious. Okay, so let's do that. So let's, we got y minus 5x on the left. And distribute through the -3, you get -3x plus 6, because -2, the -3 times -2 is +6. That's still not in slope-intercept form, because you have to add the opposite here and line up like terms, as I'm showing. Okay, always line up like terms, and you get y is equal to 2x, because 5 minus 3 is 2, so you get 2x here plus 6. That right there is in slope-intercept form. Okay, y equals mx plus b, slope-intercept form. The slope's 2 and the y-intercept's 6. That's why they call it slope-intercept form, because you can see both of them. All right, the names come directly from what it is. Okay, in this chapter right here, it's pretty self-evident. All right, is -3/4 is solution to the equation? So what you need to do is substitute it in. So x is -3, y is 4, and you substitute in. So here we go. So you get 3 times -3 plus y value of 4. All right, is that equal to -6? I don't know. You gotta work it out. So -9 plus 4 is at -6. -9 plus 4 is -5, and of course -5 is not equal to -6. That's false, and that tells me that -3/4 is not a solution. You actually have to tell me that. So if you don't, then you haven't really answered the question, have you? So saying true or false is not enough. You have to tell me what it implies. Is it a solution? Is it not? Okay, in this case, it's not, because this is not a true statement. It doesn't satisfy the equation. That's how you test any point, by the way, whether it's a equality or inequality. The second one here, number 3, is an inequality. X is 6 and y is -1, and you want to take that and substitute it and check it out. So is 6 minus 7 times -1, because y is -1 here, is that less than 14? I don't know. I'll put a question mark there. So simplify. -7 times -1 is +7. All right, notice that I see the double negative there. I get 6 plus 7. Is that less than 14? And the answer is no. Excuse me, yes, because 13 is less than 14. That's true. All right, so this test point, which is 6, -1, is a solution. Okay, that's all you do. Substitute in, use order of operations, and simplify it. Here, given these x values, find all the y values and show how you calculate it. I said show. All right, so y is equal to 4 times the x value. You got to take x and substitute it in. That's going back to basics, right? 4 times -2 minus 1. Well, let me see. This is -8 minus 1. That's -9. Second one, 4 times -1 minus 1. -4 minus 1 is -5. Third one, well, 4 times 0 minus 1. That's just 0. 0 minus 1 is -1. Fourth one, 4 times 2 minus 1 is 8 minus 1, or 7. All you do is substituted in. So you take -2, substitute it in, -1, substitute it in, 0, substitute it in, 2, substitute it in, and then you follow the order of operations. Okay, that's how we've done it since middle school. Substitute in and evaluate. Okay, substitute in and evaluate. All right, that's all you do. Okay, now number 5, find the slope or the rate of change. Now slope, you have to know, and rate of change are the same. All right, so you need to figure out the changes first. So for the change from 9 to, or the increase or change from 9 to 15 is a positive 6. That's called delta y. The change from 2 to 5 is obviously plus 3, and that's called delta x, because these are x values, or change in x. So your rate of change is 6 divided by 3, which is 2. It's that simple. On number 6, there's no change in y. Okay, the change in y is 0. Here, there's a change. Okay, 5 minus a -2 is 7, so it's a change of 7. That's delta x. All right, 5 minus a -2 is positive 7. You add -2 to 7, you get 5. Okay, so what you do is you take 0 divided by 7, you get 0. All right, 0 divided by 7 is 0. It's not undefined. Okay, you look at a calculator here, and this is what I told many of you when we first started doing this, because a lot of you guys don't know what 0 divided by 7 is. You use a calculator and you check it. It's simple. 0 divided by 7. See? 0. The reason why is because 7 times 0 is 0. Just like 6 divided by 2 is 3, and the way you checked it is you take 2 times 3. Well, guess what? You get 6. That's how you checked it in grade school, like in 4th grade, right? Well, you check this one. You check by taking 7 times 0. 7 times 0 is 0. That's why you know the answer is correct. There's your little check. You multiply 7 times 0, and you better get the numerator. Just like you multiply 2 times 3, you better get 6. Use grade school math. Okay, number 7. The change from 4 to 3 is a -1. That's delta y. There's no change in x. That's a plus 0. That's a delta x there. So on this one, you get -1 divided by 0. And my friends, you can't divide by 0, so this is undefined. And it says find the slope, calculate the slope. Well, guess what? The correct response is no slope, because this expression is undefined. Undefined means there's no number. Okay, no number for it. Try it. -1 divided by 0. Okay, guess what? You get an error because you cannot divide by 0. Let's write that down. You cannot divide by 0. Okay, you never could. Even in grade school, they told you that. You cannot divide by 0. All right, so the correct answer is no slope. Yes, it's undefined, but that implies no slope. So let's highlight that. Okay, I was looking for that, no slope. And then if you plotted these, you get a vertical line. Okay, so if you plotted these and you go right 2 up 4, 1, 2, let me switch colors here. So 1, 2 to the right, 4 up, and then 2 right, 3 up. It's right here. See, it's vertical. Vertical lines don't have slope. Vertical lines do not have slope. Do not have slope. Only hills do. Okay, vertical lines are like cliffs. All right, cliffs don't have slope. So the correct response is no slope. I've already said that 3 times. Okay, number 8. Calculate the slope rate of change again. I switched the problem. So calculate the rate of change from 7 to 13. Well, that's a plus 6. From 4 to 1, minus 3. So delta x is minus 3. So you have 6 divided by a -3, which is a -2. And that's all there is to it. All right, given the relation, which is a set of ordered pairs, find the linear function by point-slope form. Let's highlight that. Reading the directions by point-slope form. So guess what? You have to know that. Y minus y1 is equal to m times x minus x1. So you need a point and a slope. We got 4 points. The only thing we need is a slope, so let's find it. So here I see +4, here I see +2. Right here, this is +6, this is +2. Whoa, what happened here? +6. I'm sorry, this is +3. This is +3. No, +6, I'm sorry. God, it's 4:30 in the morning. I made a mistake. 13 and 6 is 19. Okay, so I thought I had a problem there. See, in linear functions, the rate of change must be constant. So the slope, or the rate of change, is 6 divided by 2, so the slope is 3. So I take 3 and I substitute it right here. Now I need a point, so let's pick this one. So you have y minus, so let's say 13 is equal to 3, because the slope's 3. I just calculated it. Times x minus x1, which is 5. It says use Poinsot form. If you don't do that, then you're not following the directions, are you? So you distribute and then add 13. Line up like terms. So you have y equals 3x minus 2. Okay? This is the end result by Poinsot form. So you have to follow the directions here. Some of you guys, I noticed, didn't do that. So make sure you do that. Because there's 2 ways to calculate the linear function. Okay? There's using Slope-Intercept Form and using Poinsot form. This is Poinsot form, which is this right here. Okay, here's your linear function. Okay, so let's continue. Graphically find f4. Well, you gotta graphically plot this, right? So let's plot it. So there's your slope and your y-intercept. So you plot the function first, go up 3 right 2, 1, 2, 3, 1, 2, 1, 2, 3, 1, 2. All right, and then you take out your straight edge, all right, because I said be accurate on these things. Okay, so there's the graph. So you graph first, and then you evaluate. So x is 4, but what's y? Well, find 4 on the x-axis, and guess what? It's right here. So this point right here is 4 comma what? Well, you just look over to the left. It's 4 comma 3. So there's your y value. That's how you do it graphically. I was looking for that on your test. All right, the y value is 3. But how do you do it algebraically? Well, you take your function f of x. All right, it says 3 halves times x minus 3, right? Well, you take whatever x is and substitute it in. And here, x is 4. So to find f of 4 algebraically, you take 3 halves times 4 minus 3. Well, let me see. 3 times 4 is 12, divided by 2 is 6. So this is 6 minus 3, or 3. So f of 4 is 3. And notice, y is 3 here, y is 3 here. And these, my friends, better be the same. All right. If you take out your lesson, in which when I gave this lesson, we did a ton of these, like 10 of them. All right. The graphical result better match the algebraic result. All right. That's how you know you did it correctly here. All right. So you first do it on the graph, and then you do it algebraically. It's that simple. Okay. On this one, you want to find the x and y intercepts of this function. So let's write it down. 3x minus 4y equals 12. All right. When you find the intercepts, you let x equal 0 and find y. So let's do that. So 3 times 0 minus 4y equals 12 gives you negative 4y equals 12, or y equals negative 3. So there's your y-intercept. The other one, you let y equals 0. So 3x minus 4 times 0 equals 12 gives you 3x equals 12, which is obviously 4, right? 3 times 4 is 12. There's your y-intercept. To graph them, all right, you can graph the line from here. So you can plot 0, negative 3 here, and 4 comma 0 here, and then graph your line, right? That's how we did it. It's that simple. You find 2 points determine a line. Oh, I got to draw it through here. So that's one way you can graph the line. The other way, as I asked in the directions here, is to isolate y. So let's take 3x minus 4y equals 12. I always add the opposite of x first, always. That's how we've been doing it for the last, well, since middle school, because you studied this in middle school. So negative 4y here, always bring down the sign of the number here. It's being subtracted, so it's negative. And here, instead of writing it as 12 minus 3x, you're going to write it as negative 3x plus 12 in slope-intercept form. Divide everything through by a negative 4. All right, and you get y is equal to positive 3/4. There's your slope. X minus 3, because 12 divided by negative 4 is negative 3. Your slope and y-intercept are given. And notice that this right here, the y-intercept is right here. There's your y-intercept, so that matches, which is a good thing because it has to. And the slope, up 3, right 4, that matches too. Up 3, right 4. So there's your slope. So your intercepts, your x-intercept here, your y-intercept here, should match everything you do on method 2. These should back each other up. And if they don't, that means you made a mistake. All right. This lesson right here in standard form was section 5.5. I believe. Let me see. Yep, look at that. Here's lesson 5.5. All right. And notice that I did the same thing. All right, so all you have to do is study your notes because we've done this stuff before, okay? All right, let's get back to the test here, wherever it was. Okay, so next one. Number 11, calculate the rate of change. The rate of change between each pair of points. We did this before on an earlier example, so I need to calculate the rate of change here. And it says between each pair. So here it's this is the first pair of points, right? From 75 to 95 is a rate of change 20. From here, from 10 to 12 is obviously 2. So this gives me my first rate of change. So delta y divided by delta x is equal to 20 divided by 2, 20 divided by 2 is 10. It says between each pair of points. So I got to do it again. So from here to here, 95 to 125 is a change of 30. Right here, from 12 to 15 is a change of 3. So that gives me my second rate of change. So 30 divided by 3 is 10. And notice that it's constant. But does it stay constant? I don't know. So let's figure it out. So my next rate of change from 125 to 165 is a change of 40. From here, it's a change of 4. So that gives me my third rate of change, which is 40 divided by the 4, which is 10. So I calculated the rate of change between each pair of points to determine if the rate of change is constant. Is it constant? And it is. Because if you look at these rate of changes, they're constant. Which means it remains the same. All right, so that tells me that we have a linear function here. So since the rate of change is constant, this represents a linear function. Believe it or not, you had to calculate 3 rates of change here. One is not enough. All right, because the rate of change on the y values is not constant. The rate of change of the x is not constant. All right. However, the rates of change between each set of pairs is constant. Okay, there's a big difference here. Okay. Now, how do you classify lines? How do you know when they're parallel? Well, parallel means that they have the same slope. This is section 5.6 in your notes. How do you know when they're parallel? Well, the slopes are opposite reciprocal. Slopes are opposite reciprocals. So take out your notes and read them, because that's what we went over here. So what to do is you explain by analyzing the slopes. And if you don't do that, well, I guess you don't know what you're doing. The only way to see the slope is to isolate y. Okay, so you got to divide everything through by 3 here to get y isolated in the slope-intercept form. So on the first one here, you get y equals negative 4x plus 2. On the next one, you got a little bit more work to do. So you got to add the 2x, and you get 8y is equal to 2x plus 16. Divide by 8, and you get y is equal to 1/4 x. Right, 2/8 is 1/4 plus 2. Now if you compare, there's your slope. There's your slope. And guess what? These are opposite reciprocals. So since they're opposite reciprocals, all right, that tells me we have perpendicular lines here. So you have to justify it. If you don't tell me that, then you're not explaining well. I mean, you have to explain by analyzing the slopes. Compare and tell me what it means. Same thing on the other one. Here, you have to get it in slope-intercept form. This is not. You can't see the slope well. So you get 2y here is equal to negative 2x plus 14. Divide through by 2 and simplify, and you get y is equal to negative 1x. Negative 2 divided by negative 2, or divided by 2 is negative 1, or just negative x plus 7. There's your slope. On this one here, you subtract 4x, and you get 4y is equal to negative 4x plus 8. Divide everything by 4, and you get y is equal to negative 1 x plus 2. There's your slope. And notice that the slopes are the same. So I'm going to say equal slopes. Okay, that means that the lines are parallel. Simple logic, okay? And again, if you practice what you learn back in the sections and review properly, this would be an easy question. You see, guys, the whole idea to get ready for a big test like this, covering all the sections, is to go back through the material again. And if you don't, you're going to learn the hard way. Because we're human, we forget a lot. And because we do, we have to constantly review and practice. Now on this one here, parallel. Parallel means the same slope as this. All right, so if we're trying to find an equation that's parallel to this one, and through this point, I need to understand what parallel means. Parallel means the same slope. So right here, I'm going to use the same slope. So use slope equal to 1/2. And obviously use point slope form because I'm given a point and a slope. So that tells me that point slope form can be used. Anytime you have both a point and a slope, use point slope form. Point slope form. You guys, they call it point slope form for a reason, because you have a point and a slope. Look at that. All right, the name comes from what you have or what you need. All right, so here we go. Y minus the y value. The y value is 5 equals slope of 1/2 times x minus the x value, negative 2. Notice the double negative right there. So I have y minus 5 is equal to 1/2 times x plus 2. I simplify first, then distribute. And then I get y minus 5 is equal to 1/2 x plus, well, 1/2 of 2 is 1. So I get 1/2 x plus 1. Add 5. And I get y is equal to 1/2 x plus 6. Here, same idea, but this time, it's different. Perpendicular means I do not use the slope of negative 4. I use the opposite reciprocal. Okay, so m is equal to positive 1/4. It's called the opposite reciprocal. Okay, you got to take opposites and signs. So that's, if 4 is negative, then you go positive, and then you reciprocate it or invert it. Simple. And then you have your point 4, 5. So you always start with point slope form. This is section 5.4 in your notes. Okay, we did 2 full lessons on this and practice from then on. I mean, we use this a lot. I told you guys it was super important. And you see it all over the place, okay? Y minus 5 is equal to 1/4 times x minus 4. Distribute through 1/4 times x. 1/4 of 4 is 1. 1/4 of 4, well, that's 1. Add 5. And you get y equals 1/4 x. 5 minus 1 is 4. There we go, 1/4 x plus 4. That's what I was counting on. Okay? Okay, a little bit of testing. Okay, so let's substitute in 2. Is that less than or equal to negative 2 times 3 plus 3? So is 2 less than or equal to negative 6 plus 3? I don't know. Let's evaluate. So negative 6 plus 3 is negative 3. Positive cannot be less than or equal to a negative, so that's false. So that tells me that 3, 2 is not a solution. Okay, so in this case, again, it's 3, 2, right? So x is 3, so 3 times 3 minus 4 times 2, is that greater than negative 5? I don't know. 9 minus 8, is that greater than negative 5? Is 1 greater than negative 5? Well, positives are greater than negatives, okay? So that's true. 1's greater than negative 5, so that tells me your test point, 3, 2, is a solution. Okay, on this one, graphing inequalities, this is section 6.5. So, slope right here, and the y-intercept right here. So the slope's negative 2/3, y-intercept is 2, or 0, 2. It's called the y-intercept. Just by comparison right there. And then you start plotting here. So start plotting at 2, go down 2, right 3, and then reverse it, go up 2, left 3, and graph your line. Do this in pencil, as I was telling you guys in the lesson. Because when you test the y-intercept, so let's test 0, 2. It says test it, so let's test it. So is 2 greater than negative 2/3 times 0 plus 2? Well, that gets wiped out. Is 2 greater than 2? And the answer is no. Okay, this is false. So your test point 0, 2 is not a solution. Okay, and because of that, it's dotted. Okay, the boundary line's dotted. If you look at all your work in section 6.5 parts 1, 2, 3, and 4, you'll see this, okay? So this tells you have a dotted boundary line. Right there. It has to be dotted. Dotted boundary line. Now, then that means the solutions are not on the line. All right? That tells you that the solutions are not on the line. That's what that means, not on the boundary line. So where are they? Are they above it or are they below it? So let's test the origin, which is right here. It says test the origin. So test it. So 0, is that greater than negative 2/3 times 0 plus 2? Is 0 greater than 2? And the answer is no. Okay, this is false too. All right, so 0, 0 is not a solution either. Not a solution. So the solutions are not below it, so they must be above it. All right, that's how we learned it in the beginning, guys. We didn't learn the rules, the quick rules, make it easy until later. You test the origin. If it's a solution, then the solution region is wherever the origin is. If since it's not a solution, well, the solutions can't be below it, they got to be above it. We call this the solution region. All inequalities have solutions either above or below the boundary line, or to the left, right, or above it or below it, depending on what kind of boundary line you have. Number 17. Isolate y. Okay, so in this case right here, you want to subtract 8x. First step. Bring down not 4y, but negative 4y. That's greater than or equal to negative x plus 4. Divide everything by negative 4. Be careful to switch the inequality, so I'm going to highlight that. So what you get is y less than or equal to, all right, 2x minus 1. All right, So this tells me that it's solid boundary line, all right, and below, because I'm in slope-intercept form. That's if you know what you guys are doing. You don't have to test points if you know what you're doing, which some of you guys do. Okay. So we start here at the y-intercept to -1, slopes 2, which is 2 over 1, so up 2, right 1. So up 2, right 1, up 2, right 1, up 2, right 1, and reverse it. Okay, it's solid, so let's draw a solid line this time. All right, and the solutions are below. Okay, and if you wanted to test a point like the origin, which would be really easy to test, the origin's right here above it. If you wanted to test it, it's simple, okay? You put a 0 here and you put a 0 here. So is 0 greater than -4? Excuse me, greater than or equal to negative or +4? And the answer is no, that's false. Okay, so that tells me that 0, 0 is not a solution, which backs what I said. Okay, if they're not above, they're below. Okay, 0 is not greater than 4. 4 is greater than 0. Okay, and the last bit of graphs here. So here we go. Let's finish up. Remember, 2 points determine a line. You want to graph a line where y is 4, so make up some points. 1, 4, 2, 4. Okay, let's plot the points that we created here. Remember, y has to be 4 here, not x. So these can vary. These x values can be any x values you want. Okay, it can be any number you wish, or you want here. All right, but y must be 4. It's constant. It's called a constant function. Y is constantly 4, it doesn't vary. Okay, so let's graph these. 1, 4 is 1 right and 4 up. Okay, 2 right, 4 up, right here. So guess what? It's a horizontal line going through 4 on the y-axis. All right, all horizontal lines have this this form right here. Any horizontal line, or any function that has the look of y equals some kind of constant, all right, you can know it's horizontal. So you just look at the number here, find it on the y-axis, and draw a horizontal line. My experienced students do that. They don't need 2 points. You just find the number on the y-axis and draw a horizontal line. It's as easy as that. This one right here is an inequality, so this one behaves a little bit differently. On all inequalities, they have solution regions. Okay, the solutions are off a line, because this right here is x greater than -3, not x equals 3. X equals -3 is the boundary line. So we graph the boundary line first. So we need to pick a couple points where x is -3. So how about -3, 1? How about -3, 0? How about -3, 5? Notice that x is -3, not y. So let's plot. So you go left 3 up 1, left 3, we'll just left 3 up 5. So notice the boundary line's vertical in this case. So this right here, this is vertical. Any function that has x equals constant is vertical, always. Anything that has y equals a constant is horizontal, always. Now you just have to graph it, and so x can't be -3, so you make it dotted. Okay, or the x values that are greater than 3, well, guess what? They lie to the right of -3. We're talking about greater than here. All x values that are greater than 3 lie to the right. Okay. Now, number 20, the boundary line is y equals -3. All right, the boundary line. You just make it an equal sign, guys. I mean, the boundary lines are simple. You just write it as an equality, and then you graph it. okay? And it says greater than or equal to, so I know y can be equal to -3, so I know that in this case it's going to be a solid boundary line, whereas before is going to be dotted. Why? Because it's got to be greater than -3. So x is cannot be -3 in that case. But over here in number 20, y is, we need to pick 2 points where y is -3. So how about 0 and -3? How about 1 comma -3? How about 2 comma -3? Notice that y is -3 here. So plot them. So 0 -3, 1 -3, 2 -3. Okay, and there's your boundary line at y equals -3. And then all you do is have to ask yourself, where are the y values greater than -3? Well, they're above. Okay, if it said less than, I'd go below. But if you just look at the y-axis here, numbers grow bigger upward, not downward. So use your common sense. Okay. If you go back to, let me see, this is section, I think it's 6-5 parts 3 or 4, 3 and 4 in your notes. Okay, take it out. We did 8 of them in a row, and they were in your homework in the textbook. Okay, so you guys need to practice what you've learned before, because we've done all this stuff before. You just got to get practice and get good at it. All right, which is something that you probably didn't do prior to the exam. You have to practice. Just because you did it before doesn't mean you fully understand it, doesn't mean you get it, doesn't mean you retained it, because we're human, we forget a lot. All right, so you have to go through it again. It's just a human condition. All right, now look at this. This is x less than 4, so I know it's a dotted boundary line because x cannot be equal to 4, so it's a dotted boundary line, first thing. Okay, the boundary line is x equals 4, so let's start working on that. So 4 comma 1, 4 comma 2, 4 comma 3, x is 4. Okay, look at the x variable here. How about 4 comma, 4, not 5. 4 comma 0, how about 4 comma -1? You just make up points where x is 4, right? And then you plot them. So write 4 up 1, write 4 up 2, write 4 up 3. Look at this, it's simple. And you draw your dotted boundary line. All right, where are all the x values less than 4? Well, look at the x-axis, 3, 2, 1. Just look at the numbers. Numbers get smaller or lesser to the left. You have to use your common sense and look at the values on the number line. So x values, x coordinate, x axis, look horizontally, all right? And you go left, all right? X values get smaller to the left, not to the right. There you go. And again, this is section 6-5, parts 3 and 4. Use your notes, practice what you learn heavily before a test. It takes a lot of time before a big unit exam to get good. And you guys are learning that what I'm saying is true. Okay, if you don't put in the practice, don't expect to pass a unit exam. Just flat out don't expect. You have to practice, and you have to go back and practice every single section. So when I say crazy things like study, practice at least 4 examples in every lesson, I mean it. Okay, this test covers everything. All right, and you guys were responsible for it, and that's why I said in class here to practice and review. That's why I gave this review out here, review 3, which I sent out. I sent out a video of this. It practices, it goes over everything. But did you go through this? Did you use my video? Did you guys correct it with my solutions? Did you do that? Probably not, if I analyzed your work. So you got to start making changes, do things better, do all the reviews. And then the thing I had you guys do before the test was this right here. I had you pick at least 4 problems from each section we've covered. Okay, did you do that? And the answer is probably no, not well. So you got to change that, is what I'm saying. Okay, in order to perform well on a unit exam like this one that covers everything, you got to practice. Okay, this is step 1, doing corrections. Step 2 is to practice again, and I'll talk to you about that in my next video. I'll talk to you then. Mr. Ainsworth, I'll see you in my next lesson.